Hello, this is structural analysis second, chapter 1, indeterminate structures, types of indeterminacy. Static indeterminacy ds is equal to internal static indeterminacy dsi plus external static indeterminacy dse. Kinematic indeterminacy dk, that is possible displacements or degree of freedom. The value of dsi, dse, ds for beams, frame and truss in beams, that is 3c, in frame 3c for 2D structures, 6c for 3D structures, in truss m minus 2j minus 3 for only 2D structures, for 3D structures m minus 3j minus 6, 3j minus 6. DSC value is r minus 2, r minus 3, r minus 6 for 3D structures, r minus 3, r minus 6 for 3D structures. ds is equal to dsi plus dsc. This is the value for frame and truss beams. Internal hinge, that is minus m minus 1 for beams. In frames 2D structures, sum of m minus 1 minus 3 into sum of m minus 1 for 3D structures. ds is equal to 0. This is the 3 equilibrium equations. ds is equal to 0, 3 equilibrium equations. ds is equal to n, redundant force. These are the forces which cannot be determined using equilibrium equations alone. Compactability equations, these are the additional equations required to determine redundant force. So then decay value, possible displacements value, hinges, for hinges, that is only for rotations decay is equal to 1. Then rollers value is 2, rotations and displacements both. Rigid joints 3, pin joints 2, fixed support, the decay value is 0. Then formula for inextensible and extensible members. For beams decay is equal to 2j minus r plus sum of m minus 1 plus 3i minus m double dash. In frames, this is the formula. For truss, only decay is equal to 2j minus r always. Importance of beams and frames. Note, m is equal to number of members connected with internal hinge, m double dash count column and beams. Then find the total degree of static and kinematic indeterminacies. This is the frames, that is the internal hinge, this is the fixed support, hinge support, fixed support. Here number of reactions is equal to 10, number of joints is equal to 12, numbers of closed loop 1 2 3, that is 3. dsi is equal to 3c minus r dash. R dash means sum of m minus 1 internal hinge, that is 9, minus 3 is equal to 6. And then dsc is equal to r minus 3, that is 7. ds is equal to dsi plus dsc, 6 plus 7 is equal to 13. Then assume inextensible members. Decay value is 3j minus r, sum of m minus 1 plus 3i minus sum of m dash count members. 3i count hinge only members. Line hinge only for joints, m minus 1 only for joints. 3 into 12 minus 10, sum of 3 minus 1 plus 3 into 1 minus 14 is equal to 17. Then next question number 2. Joints is equal to 10, joints is equal to 16, reactions is equal to 10, numbers of closed loop 17, members 12. And then DSI calculation is 3C minus R double dash. Then value of DSI is 19. DSE R minus 3 is 7. DS is equal to 19 plus 7 is equal to 26. Then the value of DK is calculated here. 18. DK value is 18. For inextensibles, that is M dash double dash is equal to 22. And next question number 3, that is link members. For link members, note that members not considers, joints not considers, only on force considers, and that's on force considers 1, that is one force considers, that is 1, that is 2, that is 1 for link 1 1 1, that is reaction is equal to 1 plus 1 plus 1 3. Members 10, joint 6, member 10, 1 2 3 4 5 6 7 8 9 10, joint 6, 1 2 3 4 5 6, link not considers. DSI is equal to M minus 2J minus 3, that is value 1. DSC is equal to 0, DS is equal to 1. DK value only. This is the truss members. So 2J minus R always 2J minus R, 2 into 6 minus 3 is equal to 12 minus 3 9. Question number 4, this is the frame. Reaction is equal to 9. Number of closed loop 6, joint is equal to 12, and then members 17. DSI value is 13, DSE value is 19. Then DK value is calculated here, 19. Thank you for watching this video. Thank you.